Jai Hind everyone, I am Anuradha Dhumale from CSC Department, Ajay Kumar Garg Engineering College. Today my subject is Dbms and the topic is transaction processing concept. So first of all, we should know what is the transaction. The transaction is a set of logically related operations, or we can say that it is the set of performing actions. The transaction is an action or a series of action. It is performed by single user to perform operations for accessing the contents of the database. Suppose I have to transfer, we can take an example of transactions like if we have to transfer the money from account A to account B. So for that transactions, we have to perform the lots of actions for the transactions. So we can take an example like suppose an employee of bank transfer rupees 500 from X account to Y's account. This small transaction contains several low-level tasks. Second, following the main operations of the transaction is, the first is read of X and second is write of X. So read of X is the operation is used for reading the value from the database, and write of X is the operation which is used to perform the write operations. Like if we read the value from the database, then we have to perform some operations on that value which we read from the database, and now we have to write, we have to update the value of the database. So write operation is used to write the value back to the database from the buffer. Let's take example of debit transactions from an account which consist of following operations: read of X, X is equals to X minus 500, and write of X. Here read of X means the X is reading from the database. The value of X is read from the database. Suppose the value of X is 4000. Okay, now the operation is performed on that X value is X minus 500. So 500 is debited from the database. Now write of X, the X operation is performed, the sum value is decreases from the original value. So we have to write that value in the database. So here what will be the value of X? The value of X is 3500. Okay, this is the example. Let's assume the value of X before starting the transaction is 4000. The first operation, read X value from database and store it in a buffer. It reads the value of X from the database. The second operation will decrease the value of X by 500. In previous slide, we show that X is equals to X minus 500. Here the second operation will decrease the value of X by 500. So buffer will contain 3500. The third operation will write the buffer's value to the database. What will be the third operation? Third operation is W of X, that is the write of X, which write the buffer's value to the database. So X value will be 3500. But it may be possible that because of the failure of the hardware, software or power, etc., that transactions may fail before finish all the operations in the set. Sometimes what will happen? Sometimes some failures occur during the operations of the transaction. So we fail to write that value to the database. For example, in the above transaction, the debit transactions fails after executing operation 2, that is the second operation performed. After performing the second operation, the system will remain 4000. X value will remain 4000 in the database, which is not acceptable by the bank. Okay, to solve this problem, for the solution of this problem, we have the two commands, that is the commit and the rollback. What is the role of the commit command? it is used to save the work done permanently. What will commit command is done? Commit is used to save our operations, to save our actions in the database permanently. Means if we are here, we are writing w of x, but not writing here commit. If we are not writing commit operation here, then that value will store in buffer only. Okay, but after writing the commit command, this value will save in the database. Okay. Now rollback. It is used to undo the work done. If failure is occur, then we will roll back. Rollback means it is used to undo the work done. Transactions have some properties. Every transactions, every actions needs some properties to perform the actions. The transactions has the 4 properties. These are used to maintain consistency in the database before and after the transaction. For what reasons we have a properties? Transaction property is used to maintain the consistency in the database. Okay, so there are 4 properties of transaction. The first is atomicity, second is consistency, third is isolation, and fourth is durability. Okay, which are the 4 properties? The first is atomicity, second is consistency, third is isolation, and fourth is durability. Now, what is the atomicity? Atomicity is nothing but that it states that all operations of the transactions take a place at once. If not, the transaction is aborted. Means all the actions performing for transaction, means if we are performing some operations like read of x, x is equals to x minus 500, write of x. Okay, if we are performing these operations, it will perform the whole operations. Okay, it will perform the whole operations if we write the commit command, or is there if there is no system failure or any type of failure occur, then all the operations are performed at once. But what happen if is there failure occur? If failure is occur while performing the actions, then it will return, it will roll back. Okay, it will roll back. Means no single operation is performed. If failure is occur, all the operations are undo, all the operations are roll back. There is no midway. That is, the transactions cannot occur partially. Each transaction is treated as one unit and either run to completion or is not executed at all. It is performing as a one unit. Okay, it is not performing as partially. Atomicity involves the 2 operations. The first is abort operations, the second is commit operations. If failure is occur, if while performing the actions failure is occur, then the abort, if a transaction aborts, then all the changes made are not visible. Okay, this will abort, this will roll back. Okay, if failure is occur. But what happened if there is no failure? We have to commit. We have to write the commit command to save all the data, to save all the value to the database, which will write here, which will perform write of x operation here. Okay, so what commit will say? If a transaction commit, then all the changes are made visible. This is the atomicity property. Now the consistency. What is a consistency? Before in one line we can say that before and after the operations perform, the value of the data will be same. there is no change in the value of data before and after performing the various type of operation. The value of the data should be consistent. That is the consistency. Let's see, the integrity constraints are maintained so that the database is consistent before and after the transactions. Before and after the transactions, the values of the data should be consistent. The value of the data should be remain same. The execution of a transaction will live in a database in either its prior stable state or new stable state. The execution of transaction will leave a database is either in prior stable state or a new stable state. The consistent property of database states that every transaction sees a consistent database instances. The transaction is used to transform the database from one consistent state to another consistent state. What is the property of second property? That is the consistency. Consistency, the transaction is used to transform the database from one consistent state to the another consistent state. For example, the total amount must maintainable before and after the transactions. If some operations is performed, before performing the operations the value is 900, okay, and after performing the operations some transactions may be there, some transactions from one account to second account will be transferred, some money will be transferred there. So before the transactions the value of the data should be will be 900, and after the transaction the value of the data should be 900. If both the value of the data is same, that means the consistent property will be hold there. Then isolation. It shows that the data which is used at the time of execution, the transactions cannot be used by second transactions until the first one is completed. If transaction 1 is there and transaction 2 is there, until and unless the transaction 1 is completed, the transaction 2 will be not allowed to perform that some operations on that same data. Okay, if isolation, in isolation, if the transaction T1 is being executed and using the data item X, then that data item cannot be accessed by other transaction T2. If read of X is performing in T1, if read of X is accessed by transaction T1, until and unless the operation is completed or committed, the T2 can't be accessed to X data. The concurrency control subsystems of the Dbms enforce the isolation property. Now the fourth one is the durability. The durability property means if I can take an example like I downloaded some movie in my system. If I shut down that system, and after the second day I open my system and see there is a no which movie I downloaded is not there. So that is not a durability. The durability property is used to indicate the performance of the database is consistent state. It states that the transaction made the permanent changes. They cannot be lost by the erroneous operations. If some failure occur, if some system will be crashed, then there is no changes in our data. That is the durability. They cannot be lost by the erroneous operations of a faulty transactions or by the system failure. When a transaction is completed, then the database reaches a state known as the consistent state. That consistent states cannot be lost in the event of the system's failure. The recovery subsystems of the Dbms has the responsibility of durability property. That means the changes which we made in our system should be durable. These are the four properties of the transaction. The first one is atomicity, the second one is the consistency, third one is the isolation, and fourth one is the durability. Now the states of the transaction. There are 5 states of the transaction. The first is the begin with the active state. Second is the partially committed state. Third is the committed state. If some failure occur, then our system is failed state and then abort state. These are the states of the transactions. Every transactions have some states. Okay, nothing means no operations, no transactions is which cannot hold any states of the transaction. Every transaction holds the properties and every transaction holds the states of the transactions. Initially, our transaction is in the active state. The active state is the first state of every transactions. Okay, every transaction is start with the active states. In this state, the transaction is being executed. For example, insertion or deletion or updating the record is done here, but all the records are still not saved in the database. Okay. Insertion and deletion operations are to be executed, but that operations will not be saved in the database. That means our first state, our transaction is in active state. Okay. Second is partially committed state. In a partially committed state, the transaction executes its final operations. Transaction executes its final operation, but the data is still not saved to the database. Okay, like we can take an example. If we are performing some reading and writing operations, read of X, that means X is reading from the database. Some operation is performed on that data. Okay, and we write the operations. We write the operation here, means we write the value of updated X data. Okay, now here write of X operation is performed in the buffer, not in the database. Okay, the value of X is updated only in the buffer, but not in the database. See, this state is called the partially committed state. This state is the partially committed state until and unless I write here the commit operation. Okay, so until W of X, the transaction is in partially committed state. In the total mark calculation example, the final display of the total mark step is executed in this state. Now the third one is the commit state. As I told you, when I write here the commit command, the operation, the value of the X will be stored in the database. Okay. Now, what commit state? The transaction is said to be committed state if executes all its operation successfully. If there is no failure here, we can write here commit command and save our value to the database value. In this state, all the effects are now permanently saved on the database system. Okay, with the help of commit command, we save all the value, all the data in the database. In the failed state, if any of the checks made by the database recovery system fails, then the transaction is said to be in failed state. Okay, there is a various occurrence, system failures will be occur, like system will be crashed, power failure. There is a lots of reasons our system will be failure. So if our transaction is failed, then that transaction will be go in the failed state. In the example total mark calculation, if the database is not able to fire a query to fetch the marks, then the transaction will fail to execute. Okay, and the one more thing is the when the transaction is partially committed, then only that value will be in the failed state, only in partially committed. We cannot draw the arrow from here committed to failed state. Means if once a transaction is committed, then it will be in a failed state. No, Never. When only the partially committed state, when only the transaction is in partially committed state, then only the transaction will be in, if failure occur, then only the transaction is in failed state. Okay, after committed, no transaction will be failed. Okay, after failed state, aborted state is there. If any of the check fails and transaction has reached to a failed state, then the database recovery system will make sure that the database is in a previous consistent state. If not, then it will abort or roll back. Okay, it will be aborted or roll back. It will undo the all the changes we will do there. That means it will undo our work. If the transaction fails in the middle of the transaction, then before executing the transactions, all the executed transactions are rolled back to its consistent states. All the transactions will be rolled back. All our work will be undone. After aborting the transaction, the database recovery module will be select one of the two operations, restart the transactions and kill the transactions. Thank you.